so welcome everybody to this webinar. I'm John McClune. I lead the technical services team at Wolfram Research here in Europe, where we do projects for customers using Wolfram technology, very often data science projects. So today I'm going to be talking about getting started with AI. The idea is that it's going to be an introductory session that will walk through some of the very basic concepts from tools that happen to use AI within the Wolfram language, right up to the modern generative AI with things like ChatGPT. And I'm going to try and cover that in the space of an hour. So let's share a screen here so you can see what I'm seeing, and we'll get started. So right, hopefully that's sharing now. So what we're going to cover in this session is some complete basics of machine learning. What is machine learning, and how does that lead to AI type decisions? We're going to go through the basics of automated machine learning in the Wolfram language, and we're also going to look at the process by which that goes through, how you extract features, classify, predict, and test what you've done. And then we'll get into some more advanced neural networks. And at the end, we'll touch on generative AI and things like GPT. Now, as I said, this is meant as an introduction. So some of you I know will be Wolfram language users already, many of you not. So I'm going to introduce a few basic concepts of machine learning. First of all, the types of tasks, and then a little bit of basic syntax, just a minimum for you to be able to understand what's going on. So the first question is, what do we even mean by machine learning, and how that sort of gets muddled up with artificial intelligence? I mean, AI, of course, is a very vague phrase. What we've been doing for 30 years at Wolfram was called AI back in the early days, when computers were able for the first time to do things like symbolic integration or solve equations in a way that humans used to do on pencil and paper. It was called AI. These days, it tends to be applied to things that seem to be fuzzy reasoning and linguistic type reasoning. But underlying all of those mechanisms are combinations of pure logical programming and machine learning. So the logical programming is all in the end human curated instructions that describe exactly how processes should work. Algorithmic type things like symbolic integration fit into that category. But machine learning covers those areas where we are data rich and understanding poor, where we have lots of examples of what we want, but we don't really quite know what the rules are. And that's really been the underpinning of all the modern view of AI in the last 10 or 20 years. So what that is taking data and building a model. So where in the old days we might come up with an equation that describes the motion of planets and then use that model to predict the future, now we're simply going to take data and get the computer to come up with a model. So the idea is we have some data points, and at its very simplest level, you can imagine fitting a curve to some points of data is the very simplest kind of machine learning, because the parameters of that curve had to be figured out by the computer by the machine from the data. In a much more modern rendition, we're taking things like images and then building a very complicated model, much more than an equational model, that then can predict the outcome of whether in this case, the images are pictures of dogs or cats. Now, machine learning breaks down into a whole collection of different classes, but here's the most important ones. Supervised learning is where you are giving the computer the supervision of knowing what is known as ground truth, what the correct answers are. So in my previous example here, if this was my input data that I'm providing to the computer, the fact that I have labeled that picture as a picture of a cat is my supervision. I'm telling it, this is an example of a cat, this is an example of a dog. And that's the human supervision. It's particularly useful, of course, when you have labeled data, things like class recognition and predicting values, where we have examples of what happens that we want to replicate. Unsupervised learning is the same thing, but without the labels. So you are simply providing a collection of data, but you don't really know what the true answer is. You're simply trying to look for patterns. So a typical thing that goes on in that space is to look for clusters, to say people who bought products like you also bought these other products. No human has said that you are a IT enthusiast, middle-aged man, but it's identified that you are part of a cohort that has similar behavior, and that's a example of unsupervised learning. And then there's a higher level, which is reinforcement learning, which is when you get the model to gain its own feedback from the environment. So notable examples have been things like teaching computers to play Go, where rather than just feeding it millions of examples of Go games, it's effectively playing itself and learning how to play through generating its own data for doing its own supervised and unsupervised learning. And it's basically just closing a feedback loop on the other two approaches. So some of the typical tasks we have in this are classification. Can we say what kind of a thing, what group it belongs to, like whether pictures are of one thing or another thing? Prediction is another important task, which is given some inputs, can we make some numerical prediction, some quantitative prediction uh, out? And that might be a single variable like this, where we're maybe predicting the height of a child based on age and sex, but it could be multiple values that we're predicting out. But the difference is one's discrete, there are fixed categories, cats and dogs, or continuous categories that can be any value. Other examples are things like creating mappings. A common mapping is text translation, where we can figure out how to take one space of data and map it to another space of data, being the other language for the same phrase. We can predict future time series. We can try and predict things that don't look like they belong. So almost the opposite of classification and prediction. You're trying to spot outliers. We're doing things like data clustering to try and form groups and cohorts that might have similar behavior or could be treated in similar ways. And more modern things are things like chatbots, where I can have conversations with a computer and it's able to give me human-like intelligent seeming responses. So these are all underlying, the mechanism in all of these is machine learning. In the end, we're taking some data from the real world to learn a model, and we're putting some data in and we're getting some data out. And that data can be any kind of data. It can be very high dimensional, like images and video, or very simple things like numbers.